In this problem, we want to synthesize this molecule, and we're going to be using smaller molecules to accomplish that. And again, our approach is disconnection approach. And so we're going to be doing retrosynthetic analysis to come up with the molecules to make this. So now I'm going to propose the following disconnection here. That I can think of coming from epoxide as nucleophile, but I need to make it react with something that has an O. So let's say I have epoxide on one end, one of my fragments. The other fragment, if I want to have that OH and keep that oxygen, I want to make a fragment that has already the oxygen. So what I'm going to do is start with these epoxide. And to go from here to here using these two molecules this is an SN2 reaction. That two goes under SN2 reaction. And this is a nucleophilic attack, or remember that the nucleophile will attack on the carbon that is less hindered. And so you will open that up, and that would lead to the formation of the alkoxide here on one end, and I'm gonna have the other two carbons. So I'm gonna have say 1, 2, 3, 1, 3, 4. That I'm gonna have that. So what we have now is that epoxide. So that epoxide, how can we make an epoxide? An epoxide can be formed from an alkene. So I can have this alkene. And how can we make the epoxide from an alkene? We need a peroxy acid. So peroxy acid general formula will be this. But typically we use peroxyacetic acid, or we use metachloropurbenzoic acid. Simply remember that in peroxy acid, we have an extra O. So this in place here that your carboxylic acid would only have one O. So here you're inserting an oxygen. So now the epoxide, you have the nucleophilic attack here, and you will form that molecule. Okay. And so what can I do to make this even smaller? Because as of now, this fragment, so epoxide is 2 carbons. This fragment still has 5. So I'm going to make this smaller by forming this from a Wittig reaction. So I can do this if I use, now I need to have 4 carbons, so butyl bromide, and I can make this react with formaldehyde. One of the possible disconnection, you can remember that in Wittig, you can disconnect always 2 ways. You can put the oxygen on this side, and that will give me formaldehyde, and use the alkylate halide here reacting with triphenyl phosphine followed by N-butyllithium, and that'll give you the halide. And you're going to insert all of that here. So in place of the oxygen. So this is what we do. So in the Wittig, you'll be replacing this with all of that. All right. So, but that's one way. You can also make that from another disconnection approach. So here you can have the oxygen on the other end. So you can start from butylate, and the other fragment will be only 1 carbon. So methyl bromide, and again, you will need to use triphenyl phosphine and N-butyllithium to do all of that, to do your halide, which is going to be this. And here you will be inserting all of the CH2 over here. So that's two possible pathways. So what we did at the beginning is noticing the structure of here and disconnecting at this point. This comes from epoxide. I need to have that oxygen right there. So what I did is made an epoxide so that when I have that attack, that will open up and give me the alkoxide. But now going backwards, I need to make the epoxide. How do I make the epoxide? I make it from an alkene. So the alkene treated with a peroxy acid will insert that oxygen and create the epoxide. Now, how do I make an alkene? One way that we have to make alkenes is using a Wittig reaction to do that. In Wittig, you have two possible pathways. So again, it's a matter of choosing the pathway that will give you a better yield. But in this case, see, formaldehyde is very reactive. This is the primary alkyl halide, so good for SN2. Here, that's another aldehyde. It's also reactive, but a smaller substrate that will be very good for the SN2, but this is also good. But between the two aldehydes, formaldehyde is more reactive, so that probably would be a faster reaction. But both pathways will work.